Hello, Mr. Peterson here with another video about physical science concepts. Today we're speaking about solids, liquids, gases, and plasmas, or the four states of matters. In my classroom, I like to talk about this chart specifically, or table. So if you have one of these, I'd go grab that, and if you don't, you might want to pause the video now to draw this quickly. So the things that I want to talk about are the definitions. When I talk about definitions, I say, does it have a definite shape or a definite value? Speed, how fast the particles of that actual substance move, the attraction of the particles within the substance, the movement of the particles, and a picture of the particles. When I talk about the actual states of matter, I'm talking about the particles that make them up. So when I say a desk, I'm not just talking about that a desk is a solid. I'm talking about what do the particles within that look like. And a solid has a state of matter that has particles that have a definite shape and a definite value. This right here, blender bottle, is a solid. If I move it from here to here, it doesn't change shape, doesn't change volume, stays the same. Now the particles of an actual solid move kind of slow. They don't really move that fast. They're not flowing around. They don't go crazy. They are very close. They don't have very much room to move. And they have a high attraction. Now the movement within these particles means that they vibrate. So those particles actually vibrate back and forth. And if you look on this picture, it kind of looks like they're vibrating a little bit back and forth there. For liquids, liquids are a state of matter that has a definite shape, no definite shape, but a definite volume. So if I was to fill this bottle up and pour it out, the liquid would start pouring out and change shape, but it's not going to change the amount that's in there. I say that these have a medium speed, and what that means is they move faster than a solid, but not as fast as a gas. Once again, they have some close, they're very close, they have some room to move, but they're not overly crazily crowded. For attraction, I use the keyword with this one. I say that they slide. And what I mean by slide, meaning that they actually move past each other, they roll over each other, and things like that. So the particles I would draw might look something like this. Almost all of them are touching, they're very close together, and they kind of can move almost wherever they want. Now a gas is a state of matter that has no definite shape and no definite volume. So if I had a perfume bottle and I spray it out, it's going to fill up the entire room. It's going to change shape, it's going to change volume, so it's going to spread out. These particles move really fast. So they kind of go wherever they want and they go very fast. They have lots of room and they have little attraction. What that means is there's not a lot of them in each spot. They're able to move freely, and if we look at this picture, we can see. Here they are. There's a lot, they might be just as big as a solid, but when they move around, they have lots of room to move. They bump into each other, but they're not touching all the time. Now, a plasma is a fourth state of matter that's not very abundant on Earth, but is very abundant other places in the universe, such as stars, fire, things like that. It's a state of matter with no shape and volume, and they're electrically charged, meaning that they can change shape, they can change volume, and they are electrically charged. I say that these are extremely fast. What that means is they move so fast that they actually destroy each other when they run into each other. They have lots of room and very little attraction, even less attraction and even more room than gas. The keywords I use are that they are destructive or electrically charged. And I look at this picture right here because it shows that they're electrically charged by having that positive and negative signs. Now, that's just a quick overview of the states of matter and how to fill out this table. Obviously, to see some examples, we can look at the website, which I'm going to show you right now. What I want to look at are specifically, there's different things associated with solids, liquids, gases, and plasmas to help us remember what they are. So for solids, we talk about the idea of being crystalline. And what crystallines are, they're in a specific order. So this picture over here would be a great example of a crystalline solid. It's in a specific order. You can notice they each have rows, they have patterns, and things like this. This picture over here, even though we used it for a liquid, could be used for a solid because those ones, they're touching, they're kind of close, but they're not in a specific pattern. That would be what's called an amorphous solid. So this one right here would be called a crystalline solid. And this one over here would be amorphous. And what we use for those amorphous means that it's very not structured, kind of any subject, or they can move wherever they want. Where crystalline is very structured, very in line, things like that. Now for liquid, we're actually going to go to the website. So if we go to the website, we'll notice there's lots of stuff here. And I'm under the Chapter 3 resources page, which is the chapter that we're on right now. I see all these quizzes, I see all this homework. Okay, so for liquids, there's two different terms. There's viscosity, Okay, and this is a video of viscosity. What this is showing you, that viscosity is a liquid's resistance to flow. Some people call this the inertia of the liquid. Some people call it the density of the liquid. Okay, I look at it as how hard is it for that liquid to flow. So if we look at this video again, we'll see over here, this might be something like a syrup. This one on here might be something like a water. And this over here might be vinegar. So this one is flowing very, very fastly. There's almost no resistance. This one, a little bit of resistance. This one is an impressive amount of resistance. So viscosity is a liquid's resistance to flow. The other vocab term associated with liquids is surface tension. So we notice if we try to cut this drop of water right here, or these drops of water, we'll notice that they're fighting us actually cutting them. So they'll actually starting to form these spheres. Now surface tension is when I actually get through and I cut them, we'll notice you'll see them actually turn into these spheres. And that's what it is. Surface tension is the spherical drops that happen because at the surface of the liquid. The liquid is actually attracted to itself, so they come together and they form this drop. The last ones I want to talk about are the gas laws. Okay, we have Boyle's law here. So here's an animation. Now, if you wanted to find this animation, I went to the resources page right here, and here's the Boyle's animation. Same thing with the Charles. We looked at viscosity and surface tension. Those are all on the website. So if we look here, I notice on this X right here, this tells me what is my volume starting out with and what's my pressure. So I notice I'm going to add a weight. My pressure is increasing in my volume as my volume decreases. So as my volume decreases again, my pressure increases. Volume increases again, volume decreases, my pressure increases, and so on and so forth. I kind of explain it this way. If I'm on the middle of a dog pile, or if I have 19 of my friends on top of me, I'm going to be extremely squished. If I have nobody on top of me, I can lay, I can spread out, I have lots of room. The more pressure I have on top of me or things pushing down, the less volume or space that I'm going to take up. The same thing goes for Charles' law. Here's a good animation that I found on the website once again about Charles' law. I look at it this way. When I'm cold and I'm outside, if I don't have my jacket, I go like this. I get as close as I possibly can because I want to warm up. So the same thing with gases. They get as close as possible because they want to warm themselves up. Now, when they're really warm, I think of it as like if I'm in a 95-degree house with no air conditioning and I'm sleeping upstairs. Oh my gosh, that's terrible. So I lay on the bed, I spread out as much as I possibly can. I want to get as far away. Same thing with gases. As I turn the temperature up, the volume increases. They get farther away. As I cool the gas down, they get closer together. They don't move as fast and things like that. Now, once again, I'm going to showcase this website because it's super duper awesome, amazing. It's got all of these things that can help you. It's got review games, it's got links, it's got things like that. So if you're not sure about why do temperatures not change when states do, here's a link to look at it. The last one I want to show you is this one right here, is what are the states of matter? So here's my animation of a state of matter. So solid right here. I click on solid, I notice, here's the particles. They're very tight, they kind of move around, but they're in a regular repeating pattern. For crystalline, amorphous will look a little different. Now liquid, I notice I click on liquid, the temperature goes up. As the temperature goes up, my solid turns into a liquid. I can see, now they move a little bit more easily. They're sliding past each other, kind of going wherever they want. You can see there's some in here that actually are moving from where they're at. Where an amorphous solid, they'd be stuck in that spot, but they wouldn't be in an orderly fashion. I click on gas and I speed up the process again. The temperature goes up and now I have some heat going through. While this is happening, I can notice I have those particles moving around. They're free. They're moving whatever they want. They're moving all over the place. So I can see that happening. This animation unfortunately does not have plasma, but it's not the only animation that we have on the website. There's lots of things there. Here's one that has a video and a song with it. I hope this little 8-9 minute video helped you learn about the states of matter. But once again, if you have questions, do not hesitate to ask your teacher. Do not hesitate to go and ask for more help or use the website. Get on that Edmodo page and see what your friends and see what your classmates are doing. Thank you for coming aboard, and I hope that you learned some more about the states of matter.